Let's begin by identifying the cooling system components. In the refrigeration compartment, we find the RC evaporator and RC evaporator fan. In the freezer compartment, we find the FC evaporator and the FC evaporator fan. These two evaporators and fans operate independently from each other. Think of the two compartments as individual refrigerator systems controlled by a main board making decisions based on temperature sensing thermistors and the program software. On the right side of this cutaway, we can see the actual location of the RC evaporator and the RC fan. On the left side of this diagram, we see the FC evaporator and the FC fan. There are no air passageways between the two compartments. Now let's identify the remaining components. Compressor, discharge line, condenser, heat loop, dryer, three-way rotary refrigerant valve, check valve, suction line, process tube, condenser fan motor. Looking at a cutaway of the machine compartment, we see the actual location of components just identified. Compressor, discharge line, condenser, heat loop, dryer, three-way rotary refrigerant valve, check valve, suction line, process tube, condenser fan motor, three-way rotary control valve. Refrigerant flow is controlled by an electronically controlled refrigerant valve. The valve is comprised of two parts, the magnetic operating coil and the hermetically sealed rotary valve. The refrigeration inlet tube is connected to the outlet of the filter dryer. This tube is the largest diameter of the three tubes connected to the valve body. All three tubes connected to the valve body are different diameter to ensure proper installation. One outlet tube is connected to the cap tube of the RC evaporator. The remaining tube is connected to the cap tube of the FC evaporator. Connecting the components. The compressor is the heart of the refrigeration system. The compressor consists of a reciprocal piston pump driven by a permanent split capacitor motor encased in a metal case. The discharge tube connects the compressor to the inlet of the condenser. The outlet of the condenser is connected to the inlet of the heat loop, also called the Yoder line. The heat loop tube is routed around the perimeter of the refrigerator cabinet door matting flange. The outlet of the heat loop is connected to the inlet of the filter dryer, which is designed to filter out debris and remove any moisture. The outlet of the dryer is a capillary tube, also called cap tube. It connects the filter dryer to the inlet of the three-way rotary valve. The three-way refrigerant valve directs the refrigerant flow. There are two cap tube outputs from the valve. One is connected to the inlet of the freezer evaporator and the other is connected to the inlet of the refrigerator evaporator. The outlet tubes from the refrigerator and freezer evaporators merge into one suction line that connects to the compressor. Note, the process stub on the compressor is used for servicing the compressor. Theory of operation. The main control board software is designed to control the cooling system. Thermistors located in the RC and FC compartment provide temperature information to the board. All cooling and defrost decisions are made by the board based on those inputs and customer usage. Outputs from the board control the compressor, condenser fan, RC and FC evaporator fans, three-way rotary refrigerant valve, and the defrost heater. The rotary valve consists of a rotating mechanical valve located inside a hermetically sealed enclosure. The valve has three tubes attached. The inlet cap tube is connected to the outlet of the filter dryer. There are two cap tube outputs, one connected to the inlet of the RC evaporator and the other to the inlet of the FC evaporator. A magnetic coil slips over the valve enclosure. A digital signal is transmitted from the control board to the coil, and the resulting magnetic field causes the internal valve to rotate. This signal cannot be measured with a conventional voltmeter. There are three different valve positions: valve closed, valve open to the RC evaporator, valve open to the FC evaporator. On initial startup of a dual evaporator system, the RC evaporator is fed first, After that, the control supplies refrigerant to the evaporator most in need of cooling. Assume a refrigerator has been operating normally, and the board has determined the RC compartment requires cooling. Let's start off at the heart of the refrigeration system, the compressor, and follow the refrigerant flow through the system. The compressor and condenser fans are energized as a result of the control board. The compressor pulls low pressure, low temperature refrigerant vapor through the suction line from the RC evaporator. The vapor is compressed to a high pressure, high temperature vapor and exits the compressor through the discharge line to the condenser. During the first minute of compressor operation, the rotary valve is in the closed position. 1 minute later, the control board sends a signal to the rotary valve, which opens the port to the RC evaporator cap tube. The high temperature, high pressure vapor flowing through the condenser begins to give off heat and changes state to a high temperature, high pressure liquid. This high temperature, high pressure liquid then flows through the heat loop routed around the perimeter of the freezer compartment. The heat given off by the refrigerant is used to warm the exterior cabinet skin and reduce the possibility of condensation forming. The output of the heat loop is connected to the filter dryer, where any impurities or moisture in the refrigerant is filtered out on its way to the rotary valve. The high temperature, high pressure liquid passes through the rotary valve into the RC evaporator cap tube. When the refrigerant sprays out of the cap tube into the larger evaporator tubing, the high temperature, high pressure liquid transforms to a low temperature, low pressure liquid. As a low temperature, low pressure liquid passes through the evaporator, it absorbs heat and another change of state takes place to a low temperature, low pressure vapor. This vapor continues through the suction line to the compressor, where it is again compressed and the process continues. When the temperature of the RC compartment reaches the set temperature, the compressor shuts off. When the FC compartment requires cooling, the rotary valve switches position and the refrigerant is routed to the FC